E of x is nothing but your theoretical or expected. The number of defective bulb manufactured by the reputed company, defective is identified here. So thus the Poisson distribution used when probability of success of an event is very small. So with parameters here lambda, lambda is nothing but your x bar or arithmetic mean. Hello everyone, a warm welcome to one and all. I am Natesh, lecturer in commerce, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. We are in the Unit 3, Section 9, third semester BCom, probability distribution, and today my agenda under probability distribution in the last session which is related to binomial. Okay, and today's session is main focus on the Poisson distribution. Okay, in the Poisson distribution, here the Poisson distribution, there is a discrete random variable. Under discrete random variable, we are identified there are four types of discrete random variable, which is one is Bernoulli, binomial, and Poisson, and I for geometric, which is related to the discrete random variable. So the Poisson distribution was introduced by the French mathematician S.D. Poisson in the 1837. Poisson distribution is a discrete random probability distribution used to describe the behavior of rare event. So when the rare event means we are not able to identify a regular basis, where it is very rare. For example, road accident or defect, if you take example. So this is the majority, and if you are going for typing, there is a mistake, okay, which is a very rare event we can identify. Actually, Poisson distribution is limiting from the binomial distribution. Okay, so in other words, binomial distribution tend to Poisson distribution under the following certain condition. Okay, so the first one, the number of trial n is infinitely large when you compare to binomial of Bernoulli. So when the number of size, okay, which is more only infinite, okay, so which is nothing but n tend to infinity, n tend to number is increase here. So the constant probability of success for each trial is indefinitely small. Okay, the probability what we are exactly identified, which is very small. So the mean of NP is nothing but your lambda, or you can write x bar is nothing but your lambda or mean, you can say. So here the parameters, which is a constant for all. Okay, so thus the Poisson distribution used when probability of success of an event is very small. The Poisson distribution, why we are using? Because of a small size. Okay, so the probability what we are expecting the success, which is a very small size. Okay, in this case, and there is one standard definition. A random variable x is said to be follow the Poisson distribution if it is probability mass function given by, so in case of binomial NCx p to the power of x q to the power of n minus x, but in the Poisson distribution, so here E stands for Euler, okay, so Euler to the power of minus lambda, lambda to the power of x divided by x factorial. So here the x series is very important. Any problem if you try to solve, so with the help of x series, which is starting from 0. For example, in case of defective, if there is no defect, 0, okay, if there is no printing mistake, 0, if there is no accident, 0, so which is going for like this n numbers. So with parameters here lambda is nothing but your x bar or arithmetic mean. So here x is a Poisson variant. What and all you are observing x series value, which is related to the Poisson variant. So E stands for Euler constant, which is constant for all. So here the Euler value is always 2.7184, okay, which is a standard value is given. So the symbolically x tend to p of lambda, because when we are trying to go for solving, definitely we need to depend on the lambda value. Okay, either discrete group data or ungrouped data. So the lambda is very important. Sometimes they will specify it in the question in average, so that we can identify. Sometimes in the problem they won't specify the Poisson distribution, but with the help of examples only we can identify. Under Poisson distribution, certain features and property and parameters what we are identified. So the probability mass function of Poisson distribution is given by, so the probability mass function which is carry based on the discrete random variable. So E of x, e to the power of minus lambda into lambda to the power of x divided by x factorial. So which is a Poisson variate x 0, 1, 2 till n numbers. So the mean of the distribution is always in the Poisson distribution lambda. If you try to go for NP also, which is related to the Poisson distribution. So the variance is also lambda. The variance, which is nothing but your variance, is also lambda, which is equal. Okay. If you try to go for standard deviation inside the square root, if you are writing a lambda, which is nothing but your standard deviation. So the mean is equal to variance is a Poisson distribution, which is always equal. So the Poisson distribution is a limiting form of binomial distribution. So when n tend to infinity, but in case of finite, so easily we can predict. But in case of infinite number, definitely we need to depend on the Poisson distribution. So the probability P tend for always 0, more than 0. So here the third one, the NP is equal to lambda, which is always constant. Okay, either you are doing for the x variant like 0, 1, 2, which is always constant value. So the Poisson distribution tend to normal distribution. The Poisson distribution which is tend to normal distribution when lambda tend to infinity. When lambda is infinity means which is extending the value. So E of x is nothing but your theoretical or expected. So expected probability is equal to mean is equal to mean. Variance of x is equal to variance of lambda. Okay, and standard deviation, these are the parameters what we can identify in the probability Poisson distribution. There are important measure of Poisson distribution. How we can measure the Poisson distribution? So the Poisson distribution depend upon the value lambda. Without having a lambda value, we cannot calculate. So for that reason, we need to identify. In some problem, clearly they will specify the average so that we can assume which is a lambda value. So the average number of occurrence per specified interval, which it is only parameter because we need to select the parameters. Okay, the probability of exactly from the x which is starting from 0, occurrence 0 which is always there is no non-occurrence. Okay, so when you are expecting head, so which is related to binomial, but when you are not finding it, there is a printing mistake which is going for 0. Okay, so can be found out using the Poisson probability function stated above in the previous the definition, whatever it is there, the probability mass function. The standard deviation of the Poisson distribution always inside the root lambda you are writing. So if we know lambda, all the probability of the Poisson distribution can be obtained. Unless if you don't have, if you are not getting the value, you can't do the problem, Poisson distribution problem. So which is completely depending on the lambda value. So based on the lambda only, we are trying to go for probability mass function. Because lambda is only a parameter, because the lambda mean is equal to lambda, lambda is equal to variance. So mean and variance in a Poisson distribution, E of x which stand for the mean. Okay, so mean is equal to lambda, V of x is equal to variance of x is equal to variance is equal to lambda, which are both are same only, and standard deviation inside the root we are writing lambda. Now relationship between the mean and variance which is always equal. So in a Poisson distribution, mean is equal to variance which is nothing but your lambda. So that is in a Poisson distribution, mean and variance are same. Okay. So the next one, the recurrence relationship which is starting from 0, which is carrying for 1, 2, 3 like this. Okay, the recurrence relationship between two successive probability is given by P of x which is starting 0, lambda divided by x into P x. For example, your next recurrence value is 1. Okay, previously we already calculated P of 0. So 1 minus 1 which is equivalent to the previous x Poisson distribution variable. Okay, so the variant what you are calculated. The recurrence relationship between two successive expected frequency is given by E of x which is lambda divided by x into E x minus 1. For example, the first value, x value is calculated. So E of x is equal to P of x okay, into n. So what we are getting, so which is going for the next value. So we are trying to go for substituting. Moving forward. So there are few examples. Based on the examples only, we can identify this particular problem which is related to the Poisson distribution, just for understanding sake. So sometime they will specify suitable distribution you have to fit. So then it is very useful to identify the examples. So the number of printing mistake per page in the textbook, which is also rare event. The number of telephone calls on operator receiver per minute or per second, whatever it may be. So the number of defective bulb manufactured by the reputed company, defective is identified here. And the number of particles emitted by the radioactive sustain, which is also related to Poisson distribution. The number of suicide reported in a year, particular city, so suicide which is related to the Poisson distribution. The number of death occurring in a city in a day, that is also Poisson distribution. The number of road accident which is occurred in the city in a week or a day, so that is also Poisson distribution. So the number of vehicle crossing a junction in 1 minute, that is which is related to Poisson distribution. The number of complaint received by any particular company. Okay. So the number of customer arriving at the supermarket per hour. Okay. So that is which is related to Poisson distribution example. So the number of bacteria in a 1 cubic centimeter. Okay, for example, 1 centimeter, 1 cubic centimeter. So which is related to Poisson distribution. And number of radioactive particle emitted from the radioactive sustain in the fraction of second or minutes. So which is related to Poisson distribution. Moving forward. Fitting a Poisson distribution, which is 100%, you can expect a long question, 10 marks or 15 marks for the final examination. So fitting a Poisson distribution, okay, using a expected frequency with the help of observation frequency, okay. So a Poisson distribution has only one parameters, namely lambda. So lambda which is equal to mean equal to variance, always equal. So this value determine the distribution completely, because unless you don't have a lambda, you're not identify the lambda, you're not calculate the lambda, so we cannot go for further calculation. So to fit a Poisson distribution, value of lambda is found out. You need to find compulsory. So for that reason, with the help of examples, okay, with the help of information, we are able to identify. The theoretical probability and theoretical frequency are calculated. Now you need to calculate a theoretical frequency. So finally, table the observed and theoretical frequency are written for comparison. So whatever in the question which is given, X series and frequency, the frequency whatever it is given in the question, which is nothing but your observation frequency, with the help of observation using a probability mass function for starting from 0 to end value like 0, 1, 2, 3, then we are trying to multiply with the frequency total, which is called capital letter N, so which is giving a expected frequency or theoretical frequency. Note here, the procedure for fitting a Poisson distribution is similar to the binomial distribution. What procedure you followed in the binomial distribution, the same procedures will follow, but there we are writing NP, but here directly we are writing lambda. So moving forward, the steps for fitting a binomial distribution. First one, because in the question X series value is given and even the frequency is also given. Okay, for example 2, 3, 1. So which is nothing but your observation frequency. Now first, with the help of observation frequency and X series, now we are trying to go for Fx. So because the arithmetic mean formula here, it is very clear. Calculate the mean using x bar is equal to sigma fx divided by n, which is always giving for lambda value because the mean value is equal to lambda. where x is a observed value, f is a frequency, n is a total frequency which is given in the question. Okay, you need to take the summation of frequency. Second step, equate the observed mean value to the theoretical mean of the Poisson distribution. Now you need to equate. So for example, in some time they will specify the p value and small n value. Okay, so the lambda, if you try to, for example, the small n is 6, the probability is, for example, 1 by 100. So you have to multiply, then it is giving a lambda value. Okay, so now third step, find the p of 0, because which is starting the x series will start from the 0. So that's what we are trying to go for, using a probability mass function with the help of 0 first value. E to the power of minus lambda, theoretically probability of x of 0. So using a Poisson probability function, So p of x which is starting 0. So e to the power of minus lambda, because with the help of first step we get to know the value of lambda. So now into lambda to the power of x, because we consider 0. So we are writing 0. Now here also 0. So now using a Poisson variant. This is your Poisson variant. Okay, 0, 1, 2, 3 till x number, last number. The first step, find the theoretical frequency of x0. Okay, so now theoretical, after finding immediately you need to multiply the frequency total, now which is already calculated in the third step. So you try to multiply with the frequency total, then which is giving a theoretical frequency or expected frequency. Now whatever you are getting the value, now round off the theoretical frequency to whole number, so that the total frequency which is equal to n. Now last step, write both the observation and theoretical frequency in a table, so that the comparisons can be easily made, which is not compulsory. Then also you, if you want, you can prepare the table. Okay, keep on watch for next section. Thank you.